Okay, so here, from here, this display flights.
Cell 26. Just give me a moment. Let me log in right. Logging to.
Mm.
Okay. So basically, wherever you are, when you are finding this minimum distance, right?
Mm-hmm.
So before this cell, what we
Okay.
what we need to do is, because we are getting the data in the, basically this is a standard procedure whenever we are getting that sort of data. So what we can do is, like, we can convert some of the data sets which we want, because what happens, like, whenever we are loading a CSV file, so CSV file always loads everything as string format, right?
Okay.
So
Mm-hmm.
initially, in the starting itself, if we want, we can just convert those fields which we think, okay, this should not be the string format, this should be double or float or in another format. We can initially do that. So this way, and when we are going to apply any sort of uh, uh, mathematical expressions, or we need to calculate something, so that becomes easier for you
So
know
is there any if it is, if we are going to do it in initially, so you are telling that we are going to do it directly in the CSV file.
Yeah, that
Or,
that no, not in the CSV file. When we have
okay.
loaded it, after loading it, we can convert those stats into using cast or try-cast at that point of time. Or if we want to do it manually, or we can just create a function to create based on the data itself, like what kind of data it is, so we can convert the type into that type directly. So we apply that function onto that particular data set or data frame, so it will automatically change its data types,
Right.
right?
Mm-hmm.
So this way
Mm-hmm.
we can do it.
Okay.
So
So applying tycast or using the functions, we have to initially, if we think it is not, if it is not a string or if it is not a float, we have to do those transformation initially is what you mean, right?
yes, yes.
Okay. Okay.
Okay, so now you need to run it again, right?
Run it again. I can run here from here, right? From the
No,
24th cell.
no, no.
Mm,
If you are going to, because you must have you know stopped it. So automatically, what happens is like if your if your notebook is not running for a longer period of time or after some point of time, because it's a serverless compute, so it automatically disables it. So if you are going to run it again from in between, so it will say like all the above data frames are going to be lost.
oh, okay. So is there any time period like this many hours after? I thought I once you said it's been a week, so
Yeah, you
uh,
don't need to run this again. This cell, you don't just come down from where I tell you. Yeah, from cell number 4, you can just start running.
so how many hours we can continue doing it
No, no,
if
it's a serverless. So if you are not using for, let's say, 10 to 20 minutes, it depends because they need to, save the resources. So generally, if we are working with our own, interactive mode, interactive cluster, or we call that, I told you two types of cluster, job cluster and interactive clusters. Or so job clusters are automatically, created.
Mhm.
Okay, now it is giving the error again, right?
Okay, you share your screen and you can start because
Uh,
I thought I can start from 24th cell, so that's why I thought I can do it. So
no,
if
no,
it is from
yeah,
the
that's
beginning,
fine. I'll share you the updated file also, right?
okay,
So that you can just check.
okay, I'll stop sharing. You can
Uh,
start it.
so I also started from this cell. Previous cells I've just deleted. So let me run this. Yeah, it's run. So here we already discussed. We are just create. Okay, no, just running. Yeah, it's done. So we are creating the Spark and just uh, checking it. Now here we are creating some libraries, pandas, NumPy, importing them and creating some PD temp, Spark temp, and just creating what all tables that we are having in within the catalog itself. This way, these we have already discussed earlier also. The next cell, what we are doing is like here we are loading this file from this particular path. Here we are just setting this file path and then setting my headers are true. Let me just change it to this link. See, everything here, if you see, it's ABC, 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 ABC. Even my data is not, you know. So what we can do here is like if we want, like, so either we can, after loading this file also, here based on this data, let's say this is altitude, this is time, some another field is there. So these four fields, latitude, longitude, alt and tz, we can convert these into specific, let's say, these two into float. These two are integer values, so we can convert them into integers, right? And then we can use them, or we can do it like the way that we are doing right now, like whenever required, like let the, you know we don't have to do anything with this, but we have loaded the data into this airports.
Sorry for interrupting. So you're telling that we can change the data types for the particular column, right? Not for the specific values.
Yeah,
Am
yeah,
I
just
right?
we have to just change. Yeah, we don't need to change the values. Values, we are not going to do anything. Values will be changed when we are applying something. Let's say we are doing some transformations, but here we have to just change the data type of these, because by default, whenever we are loading a CSV, it loads in the Excel format, because in CSV everything is considered as a string, nothing else. But if we are working on other file types like JSON, so in JSON, whatever the data is coming, so when we are loading it, so Spark loads the data, or if we are using Pandas, so as it is, like in which format we are getting. Same for with Parquet, ORC, RC. There are a number of file formats, so they take it as it is. But in case of CSV, it just takes everything as string, right? So after this, what we can do is, like here it is showing airport as a data frame. So here, if I can do one thing, I can ask Genie, just create a function, because it's easy to apply, to convert the data of airports. Airports. Accept, and let me change this. So what we are doing here is, like, we are getting the data types, changing what are the columns are there, and selecting all those columns, and just checking its type, like in the sense of if it is an integer type, string, or is some sort of digits in the data sets. So changing to based on their values, right? And if it is like it is, this function will work for all the all the different data types, and then we are applying this infer and cast types to airports, and I'm converting into a putting into airport type 2. Okay. Serverless, it's not, about some limitations. So you see, still it is not able to convert. So just showing all our strings. Pass into integer type here, float, boolean as well as string type, but just taking everything else. Okay, I think there is some issue with this, serverless. Right?
Mhm.
It's not doing it, but yeah, this is what we generally follow to convert the data types. Another, like, this is through the function itself, but we can do it like the way that we are doing it. I'll check it again, like why still this is not working in serverless. Then we did it all to get the list of. This is another data frame that we are uh, data set we are adding into flights. Here we have got year, month, day, department delay, departure time, departure delay, arrival time, arrival delay, carrier, flights, origin, destination, air, time, distance. This is all we have given in string also only. Same here, we are just creating a timetable with the name flights. And here we are just reading that file with the just right. So here within the flights underscore data frame, we have created a flights table above from the data frame, one data frame, and then we have reading that flights temp table as a table using spark.table. So directly we are using it, and then we are just loading that table into a data frame. So in the above one, what we are doing is here we have created this flights data frame into a temp table, and this is the back and forth. So it's just as I already discussed, like we can convert to and from a we can convert data frame to a table, and then from table back to the data frame. So it's based on that. Like if we want to do our transformations on SQL side, so we can convert that data frame into load the data into a data frame, and then convert into a timetable and do all the transformations in SQL, and then convert back my final output into the data frame itself, and display it. So based on my requirement, I can do that. Like sometimes my I'm not able to, let's say, the performance or the complexity. Based on that, I can just uh, convert to and fro. So here, if you see, we are converting duration hours into float, basically this air time. So we are taking air time as float and then dividing it into divide by 60, and we are taking it as duration of hours, right? So yesterday we also did this. And see, the duration is of type float. Next, this is just describing what the data we are having with when we are doing this display. So it shows five records, some sample records. Here we are just filtering it. So we are filtering based on the distance. Wherever the distance is greater than 1000, we are only getting those records. See, distance, go to the distance just to check. Yeah, if you see, and from here you can do the sorting with based on ascending or descending order. So we have did in ascending order. You see, every value is going to be more than 1000 only. Similar way, if we want, we can just change the filter, apply more filters, whatever is going to be with the help of filter, or we can also use where clause also. Then here, this is the same actually, but here what we are doing is there we were directly doing distance, but here we are applying the filter with data frame dot filter name. So this generally we do when we are applying it, like maybe we are working with the different data frames, and where the distance can be there in more than one data frame. So then the Spark will get confused, like which one we have to work upon, like which distance we have to take it. Let's say from flight 1 or flight 2, let's say we are having two different data frames. So in that way we can also specify data frame name dot column name, and then we apply this filter. Again, this was for selecting specific columns. If we are selecting, let's say, tail number, origin and destination, so we can do it instead of if we are just putting flights only, so it will give me all the columns. But if I need to select only few columns, as I yesterday also mentioned, so this is another optimization technique. Like I'm getting 100 records in my original data set, but I need only 10 or 15 columns, which are going to be part of my final output. So why I'm going to use all those 100 columns, bringing the data? So it basically uh, used for. So it is the best practice to select only those columns which are actually required. So this is again used to be called as the best practices when we are developing our code. Here again we are same selecting using data frame name dot column name. So this way also we can do it. When the only thing is difference is like when we are basically selecting only columns, so we have to do it with quotes, and when we are doing it with data frame, so we have to call it without quotes, because it's my if we are taking the within the quote, so it takes it as string at only, so it will not going to parse it as we are having. So it will take it as flights dot origin as a one column. So that's why we have to take them as. Here what we are trying to do is we have created a filter directly. Like previously we have applied directly filter, but what we can do, like when we are having more than one filters are there, or filter condition is going to be quite long, so sometimes you will see we have to apply very long filters, let's say 5, 10, even 20 different conditions are going to be there as a part of that filter. So what you can do is you can just create the filters first. So here we have created the filter A as flights, where the flight dot origin is SC, and destination is PDX. So these two filters, and then we are applying those filters onto my data frame. So I'm applying it on temp data frame, filtering on first on filter A and then on filter B. So I applied two filters and then displaying my data set. So in this, we are only getting, destination where destination is PDX and origin is SCA. So only those records, and we are taking one more, as in my TAMP data set, if you see, we are only having these three, columns. So if I want to add more columns, so only then I'll going to get the data, or I can apply this to, instead of temp, I can apply to my flights data set also, right? So it will work on then on all the data sets. Okay, now it's saying temp is not defined, so we have not run the upper cells, I guess. Temp. Yeah, this one. Because we are selecting, so you can see, like, until unless you are not going to run the upper cells, where this, so this is also called the lineage, right? So this is how the lineage is working. So I forgot to run this, and directly when I'm running it, so this particular temp is not available because we have not created it. So these are all in between temporary data frames. So once my compute is stopped, so we have to, that's why we have to run them again, right? Let me run this, because here we are defining those filters. And now it will run. See, if I'm saying control enter, so if you don't want to click it here, you can directly within the cell and just click control enter, so it will run for you. If you want to run it directly from the keyboard, right? You don't want to do it again. This is what we are trying to do, is like we are finding out some average speed. So my distance column, how I'm finding out, like, distance column, and then because airtime was initially it is given as string, so we are converting it using try-cast and evaluating this expression. We have already did it many times earlier. So origin, destination, tail number, and then this is my average speed that I have just created. So this average speed is basically, it's a generated column, right? Generated column means, like, whenever we are generate, this column was not existing from in the initial or in my original data frame, but I have generated it using these two columns, right? And displaying it. And one more thing, like, whenever you are doing any sort of transformation, so don't try to do it on the same data frame, because these are idempotent. So sometimes it happens, like, that's why, like, if we are using doing the transformation and just referencing to the same data frame, so what happens sometimes is, like, it malfunctions that data set. So instead of, like, if we want to do it, like, we can rename it later, but try to give it a new name whenever you are creating a new data frame out of it, because it's a lineage, and every time we are creating either data frame, RDD, or data set, it is always going to create a new one, right? It's not like they are updating the existing one. The only thing is, like, reference, if we are passing the same name, so only it creates a new data frame, but references back comes to the same variable. You understand that thing? I think Yesh might have this idea, because this is, but I just wanted to understand from Sharmila. Sharmila, did you understand what I have said right now?
Yeah.
Okay, fine. Because what happens is, like, let's say, understood, that's fine. Similarly, we are just now creating this. Now see here what we are doing, like, speed 2, within this we are creating as average speed. So what I'm doing is I'm trying casting both, because what was there, like distance is also coming out to be as my, you know, string, and this is also string. So I'm converting both. I'm try casting both, because if we have to find out the average speed, this will give me the correct, answers. Although, like in previous cell also, just to show you, it is giving these almost the answer is correct here, but there could be some, edge cases also. Like if here I have not, did converted this into uh, float, but directly did it. But it, as it was a float, so that's why it has converted into one of them. It is taking, but it will work. But in some of the cases, it might give you some, some of the edge cases. It might not work, and it may fail. So instead of doing this, what we can do is, like, we can convert whenever we are doing such, type of transformations. So we have to take this, like if both are of not of the same type, so try to convert them, right? Like it is, if it is integer, that's fine. But if it is string and another one that we want to do some sort of, some mathematical operations, so it is better to go with, both the columns, or how many number of columns, all the columns that we are working on, they should have the, similar type of data types. So then it will work fine. Although if we are having one only, it should also work fine, but in some cases it may result errors. This is fine. We are just describing what my data frame contains, what are its types here. So I was talking about, like, this is another way, right? So here what we are trying to do is, like, we have loaded data again, that small flight small .csv into another data frame called flights fresh, and we are converting these distance, air time, duration, departure delay, arrival delay, month and year, because these values should be, basically in integer, float or double formats, right? So that's why we have converted it them. This is one way, and the initial I just shown you, that was my initial another way of, converting these. So this way we can do it, right? This is sort to be, some manual work, because every time you are going to do it, like if they are, let's say 10 or 20 columns are there, so you can do it. But in some of the, in real scenarios, when you will see in some tables, even we are dealing with 450 columns, 400 columns in just one, data frame. So there, if you are going to write this way, it will take, a lot of time. So instead of doing that, it will just go and check the data set, and based on the data set, it will, convert those ones, right? So this way also, this is another way of, but this is some sort of, manual work that we generally used to do, right? I don't know why it is still showing, I think that also worked, but here it is also showing, okay. Okay, this is, we have converted something. So if you see year, month, it has converted to integer. This is float. This is arrival time. This is also float. Yeah. So it has converted into perfect. So this way we can do it. But the upper one has some sort of issues. Like, I don't know why it was giving the same. Here also, if you see, we are selecting flights. Okay, here we are selecting on the, flights. That's why it is giving Okay, so okay, but we have converted here. We have updated the values from flights fresh to flights. This should change actually. I don't know why it is giving. Is this issue with the serverless or what? But it should not. Otherwise, like you know, this month, these all should it should show us in floats values. Okay, so here we have just get the minimum value out of it where the origin is PDX. Here, if you see, this is my group by function. So what the group by function is doing is like on wherever it was PDX, it is combining all those, you know, for origin or whatever the, you know, we have got all other columns are there. It is grouping them with the minimum distance and then displaying them. See, it will take some time because it's doing group by. So group by is again a very, you know, expensive operation. A lot of data is getting shuffled. So whenever we are doing group by join, so my data is getting shuffled. So this is another, you know, expensive shuffling is one of the, you know, bottlenecks, or you can say one of the thing that we have to take care of whenever we are doing the optimization. So we need to reduce the shuffling between the, you know, between the partitions, so that if uh, shuffling is going to be less, so my performance is going to be higher, right? And from here you can just see the, you know, performance also, how much time it is taking to process this, right? How many number of bytes. So it is not processing those many number of rows, but it's still taking, you know, like almost 2 minutes. So 2 minutes just working on few kbs of data, it's a huge amount. But here it is taking more time because we are using, you know, serverless, as well as this is you know, free version. But in real scenarios, when we are going to use the dedicated resources, so there it should not, like, it will take around, you know, less than a minute to, or a minute, less than few seconds, or within a second it will be, we will be able to get the, you know, answer. Otherwise, like, if it is taking this much amount out of time, so for big data it's going to be a huge, you know, bottleneck. So I'm just trying to, you know, optimize one of my, you know, query which is taking around uh, which is quite complex one. It is using around 23 different, you know, tables, or those tables are not the direct tables, those are some materialized views, as well as streaming tables are there, and bringing data around, you know, a few of the tables are bringing data for some millions of records, and it is running, you know, every 20 minutes. So I'll tell you, like, this is another you how you are going to schedule. So you see this schedule with serverless, we have got the scheduler is there. So once we are done with the you know, building my logic in the form of, like, either we are doing it in the form of notebook, or we are writing some sort of, you know, code in VS Code, or any to develop any sort of pipeline, then we can just, you know, run that, deploy that, and schedule it. Scheduling means, like, every time you don't need to come back and run it manually. So we can, you know, schedule it, like, at that point of time, like every day, every week, or within a day itself, how many times you want to run it. So that is running 20 minutes every 20 minutes. So it means, like, in 1 hour it is running 6 times, and in 24 hours you can see. So taking, it is running for almost, whole day, because sometimes it is taking more than 20 minutes to finish. So by the time it finishes, a new, uh, schedule comes up to run it. So that's why it is almost running continuously. So it is taking around, very huge amount of time. I don't know why it is taking this. Should not take this much amount of time. Last time it ran in few seconds. But this time it is taking very long to run. Yeah, but this is really an expensive operation. Okay, let me interrupt this and show you one more thing. So let's say I'm not displaying it, and let me run this. See how much time it took? Just 2 seconds. Why? Can you answer this? I have answered it many times. Anyone of you? This is very, important concept. Yes, Sharmila.
Can you come again? I don't understand the
Like
question. Come
I
on.
have just, commented the display, and I just ran this. So previously it was taking longer time, right? It just took 1 second to run it.
It needs to display means it takes some more
Yes, but why?
time.
What is the reason behind it? What is display? Okay, what kind? What?
Display means it will show the table.
Show the table. That
It
is
will
fine.
filter and shows. Here it needs to filter, so it
Okay. What are the different operations we are having on any of the data frame? What are the different operations? I told you two type of operations, if you remember: transformation and action, right?
action, yeah, correct.
Yeah. So transformation doesn't do anything until unless
The
I'm not
action,
going to put any
any
action.
action,
So it
action is
only,
perfect.
it only creates a DAG, that is directed acyclic
Yeah,
graph. So
yeah,
here
yeah.
it has, when I'm not giving this display, so what it is doing, it is just creating a DAG. So it's not actually grouping the, basically it is not neither filtering nor grouping, and not finding out the minimum distance. Once I just hit this display, so what it
Action.
will do is now the actual processing is going to happen. So until unless I'm not going to have any action functions, nothing is going to happen. Only a DAG, that is directed acyclic graph, is going to be converted. Like, okay, my processing is going to happen in this way. So first I'm going to load the data onto flights, data frame, then applying this filter, and then grouping the data, and then finding out the minimum distance. This is how it will work. And then internally, what the Spark is going to do, Spark is going to basically create different, plans, and which is going to be the best plan at runtime. It is going to pick that up, which best means like it is based on the cost optimized plan. Like cost means like time. So whatever the plan it should take to reduce the timing, it will take it. So previously we have to do it manually, but now with the help of AQE, that is adaptive query execution. I have discussed these things earlier also, but if you don't remember, I'm just giving you the background again, right? So AQE does a lot of transformations automatically, so we don't have to do it. So from Spark 3.0 onwards, it automatically we just need to pass one parameter that okay, AQE enabled, right? once this is enabled, so automatically these kind of optimization techniques are automatically going to be done by the Spark for us. We don't need to, previously we have to do this manually, like writing the code to how and giving them different specify different strategies that how it is going to pick up those plans. But now it has become so much intelligent that it automatically, based on the the requirement and what kind of data we are getting, what is the amount of data we are getting, so it tries to create different plans for a particular query and pick up the best plan which should run at the runtime, right? So if I'm going to run it again, now it will take some time. Now it took just 3 seconds, but less than what we why it took, because now it stores the what the processing that happened earlier. It has got that result is stored in its temporary memory, and it is already there, so that's why it has fetched it earlier, right? Now this is for same, we are filtering on the basis of where the origin is SC. Here it was, I think, PDX. Yeah. So here we are applying different filter. So where the flights dot origin is C, then grouping by, here we are grouping by max airtime and then displaying it, right? Now here what we are trying to do is, like, we are filtering the flights based on carrier here. So where carrier is DL, flights dot origin is C, and then grouping by average airtime, right? And then displaying it. So for carrier DL, origin C, the airtime, average airtime was 188 minutes, right? Here we are creating again duration hours. How we are creating it? We are dividing the airtime divided by 16. Why now? Why we are not converting it? Because these are already converted earlier into this respective data types, right? And then we are just displaying it. But as if we want to run it cell by cell, so we can do it as we were doing earlier. Again, this is we are doing the group by using tail numbers. So all the tail numbers will be grouped together. So this is, I'm going to display it here. This is the count of see. So for this tail number NS N765 AS, the count was 12. For this 713, it is 31. And if we want to order by them, so we can also use the order by here. If you want to do an order by, so you can do order by count, and in which by default it is going to be ascending order. But if you want to do it in descending order, so you just need to give DES. Order by is not supported. It is in descending order, but should. That is saying it's not supported. Should be. Let me check this. What is why it is saying it's not supported? Or there is any change or what? But I'm using this DESC very extensively. Oh, ascending falls. Okay. Yeah, so I'm using PySpark, and here it is using Spark. So yeah, so in PySpark we can directly use DESC, but as we have created this using pandas, so in pandas it doesn't directly convert. So we have to pass as ascending as false, right? But if you are working with PySpark, you can directly use DESC, right? So there are different ways. Now you see, we have got like this. So based on this, we can do it. Then again, we are doing the group by origin, and so here we are not displaying it. So we can use by origin dot count dot display. Here directly we cannot apply display here. So we have got SEN PDX because initially we have done it on by origin. So that's why it is only giving for two, right? If I'm going to do it directly here, so this actually we can't on group by we cannot use directly display because we have to specify like how we have grouped it, like whether we through count or so it's gives there is no attribute. So yeah, that's fine. So what we did is we just get the count group by first origin, and then we are doing count on it. Here if I want, like I can directly use this one here, so it will work. This way it will work because what we are doing is on group by we are counting, and on count we can do the display, right? This way we are doing it, right? Then again, similar way we are doing the average on airtime. So these are all basically these are the business none type object has okay average where we are finding out the average. But you find out its average earlier. Yes, that we can do. It's not working. Cannot import f name. And type, why it is taking none type here? By origin, okay. A time. Okay. Yeah, within this origin, we don't have any. Yeah, yeah, that's fine actually. Because what we are trying to do is we are trying to display AI time which doesn't exist in this by origin, right? So let's do it in flights. Then we don't need this here. In the flights, we have got this air time, air time distance, which is not supported. Why it is not supported here? Sure. Lights dot filter to by average we get average time. But why we need to take this region is in PDX or SEA? Group by average. Oh, I got it. Because average is our aggregate function. We cannot directly use that. If we have to find out the average, so we have to find it out, using transformation. But if we are directly using average, it's an aggregate function. Sorry, that's my bad. I forgot that. Like average, count, minimum, maximum. Either we have to create them with our own functionality, or if we are directly going to use them, so we have to use them with aggregate, because these comes under aggregate function. So we have to specify, okay, we have to do the aggregation of that, right? So that's why it's like this. Yeah, here also if you see, like we are doing the average on departure delay and calling it average departure delay, grouping by month and destination. So these columns you can specify as per your requirement, but these are just how we are going to use group by group by average functions. So average, min, max, these are all comes under count, comes under aggregate functions. So aggregations, when we are going to do the aggregation, for aggregation we have to do some sort of grouping first. So based on the groups we are going to find it out. So here again we are displaying the airports data initially that we took. Now we are going to use it again, so that's why we have just evaluated with some names, latitude, longitude, altitude. So renaming with FA to destination. So basically this is FA will become destination. This is again another function which is basically used to rename a column. Apart from this, like this will rename in the data frame itself, but we can also rename using select. But select, it's going to be like select as. So this will work as the alias, but here it will change the name, from far to destination itself. Like if I'm going to display this, so now previously we were getting far, now it will be destination, DEST, right? But we can also like we can, when we are using the select also, we can do it like airport dot select, and within select like far, and we can use dot alias as DEST. Airport underscore two, let's say airport. In this column, dot alias as DEST. And I think we need to, oh, we already did, because here we have already renamed it to, so this far doesn't exist at all, right? Now it will. Why? We ran this airport. Okay, let me run this again because it has already taken over and it has converted the far to destination, but still it is saying it is not able to. Oh, has already been converted to destination. It has check. Okay, let me do it. It has already converted, so let me convert it to this to far again. Otherwise, I have to run it from the starting itself because it has already, converted back to this. See, so this way we can also, convert it. Alright. So yeah, so now we are joining it. Another concept, very important, in Spark, or like whenever we are doing any sort of transformations. So this is one of the important part, that is every time, like whenever you are doing any sort of transformations, you are building any pipeline. So this join is definitely going to be part of your transformation, because whenever we are having more than one data set, one and in one way or the other, you have to do the some sort of joining. So I just wanted to heard from you, like what do you understand by joins? What idea do you have about joins? Both of you? Joins क्या होता है, कितने टाइप के होते हैं, how they work?
So joins basically combines rows in the table. In SQL, I know about joins.
These
So
are same SQL joins. Joins are same, like,
yeah,
because
inner
whatever
join,
we
left
are doing
outer
here, whether
join.
in Python, PySpark, or Spark, joins are always going to be remain. The logic is same, right? The only thing is like basically the syntax difference is there. Otherwise, like joins are same. Apart from those SQL joins, we have got few more joins here. Like we have got SNJ, that is sort merge join is there, right? Broadcast join is there. We'll talk about them, but I'm just wanted to understand, like what understanding do you have about the joins, so that I should not go in detail, right? I can tell you, but just to make you understand, like you should have some sort of idea. So we have got, like, if I talk about joins, so we have got inner join and outer join, right?
Yeah, that is left outer, right outer.
So inner join, or you can say it's natural join also, we say whenever we have got two tables are there. So based on the condition that we specify, those are going to get the joins. So let me just tell you the, yes, let's take this, right? It basically explains the things very well. So let's say this is my table A, this is my table B, right? So when we are doing the join, so this, the common part here, within the inner join, basically this is the common part, right? See, this common part is, we are able to see that common part, right?
Yes, yes.
Yeah, so this comes under my inner join. So whenever, because both the conditions, like whatever I have got in A, whatever I got in B, so the common is which is in both. So that will go to my inner join, right?
Yeah.
So basically
There's
this is
matching values
sort
in
of,
both.
yeah, intersection, right?
Hmm. Right.
Right. So it is common in both, right? But in outer join, we have got three types of joins. That is left outer, left, right, and full. Right. So left means common. So this is whole. Left will come under this one. So I'm taking like A as left and B as right. Right. So this left whole is going to be part of my left join. Means whatever I am having as part of A as well as which was common in both. Right. So it will be going to be the part of A. Right will be whatever the common as well as, you know, which whatever we have as a part of B. So this is going to be my right, and the full outer is going to be left plus right plus common, right? So this is whole my full outer join. Understood?
Yeah.
Yes, sir.
Okay. So this is very, simple and way to understand this. So don't get confused. This is very important concept, and in whenever we are going to deal with the big data, so because in left join what happens, like inner join what happens is like we are losing the data because we are only going to get this data which is the common one, but from the left and right we lost a lot of the data. So to retrieve that data we generally go with the outer join. So in data engineering we mostly work on left joins, because we take the left table and get the data from the right table which is the common, and then we are going to do left outer join. So left join, left outer join, those are same basically, right? So it means that flights data will get all the data from the flight, and from the airports we are only going to get the data which is common in both flights and airport. And on what condition? On the basis of destination. So this is my condition. So this is how we are going to do the join. So flights dot join on what is my another data set? Airport data. On what condition? Like here you can have multiple conditions. Here we are just given one column, but we can have multiple conditions also, right? And then how we are doing it? Using left outer join, right? So if you see here, what we are doing is like we are getting around more than 10,000 records, right? When we are running it. So before left outer, let me do it inner. So in inner, I think we should get, less. Okay, it is still showing 10,000 records more than. So what we can do is just to check, we can do it count here. So how much of count that we are getting. Okay. Remove this just to count. See, we are getting 10,000 records, and let me do left now. Here also we are getting, I think in destination we are matching most of the records. So in both are those are the same. So if I'm going to do with the full, let's see how many records we are getting from left, right. Yeah, so you see we are getting around 11,324 records. And most, flights dot count airports. Just to check like how many records. 1397. So basically in airport, we are having 1397 records are there. And let's do it. Let's take the second one. $10,000. And here we have got 1,397. So total in full we are getting there are few more records which are like very few records. 97 minus 28, so it is coming out to be around 71. Not 69 records, right? 69 records. So 69 records which are not matching, which doesn't match with the destination. Rest all are matching. So that's why we are getting this. So basically, if I'm doing inner or, it means those are matching. So from the left side, we are getting 10,000 records. So those means from the left table, all are matching to the right table. That's why we are getting this 10,000 records. Then we are reading another file, which is planes. So planes.csv with their tail numbers, year, type, manufacturer, what is the model, how many engines are there, how many seats are there, and what is the speed. Speed is not available, and what is the engine type in the plane itself. So this information we are getting from the third data file that we are having with the name planes.csv. Then we are having planes. We are renaming again with the column renamed with column rename with the name year with plane year. And like if you want to do multiple, so we can use multiple with column functions with it. With column renamed, like tail number to tail number, like it's the same, just to show you. So this way, like if you want to do multiple ways, one way is like this one, or you can also use slash and do this way, just to do it that way. We can also use like tail numbers. Full we can give tail. I can give it tail number. See? Training a tail number. Likewise, we can do multiple with slash. Basically allows us to do it in the next line, right? But if we want to do it in the same line, I can do it like this way, and I can use any number of columns in this way. But this doesn't seem to be good in the sense like look and feel, also to understand someone. So it is always better to go with the backward slash and do it in the next line, right? So we don't need it right now, so let me delete it. Maybe After in subsequent cells, we are using the cell numbers. Otherwise, let me read this again. Okay, now it has been changed back to this because with column rename, it also got renamed to the tail number, right? So that's why I just need, what I did is like I have reloaded the data to my planes data frame and then again do the transformation, right? Then here, if you see, we are again, on this flights data frame, we are doing a join on planes on tail number and doing again left, outer. Also, if I just tell you, see, so you see left, anti-left, left anti means like opposite of what the left is doing. So what it will do, like whatever we were getting as a part of left anti is going to get the opposite of what, like it will only get the records from the right side, which was not matching with the left. Then left outer is same, left semi is also, it will only going to take the records from the left. It will remain the it will eliminate those common ones. And left anti and this left anti are same, left outer and this left underscore outer is same, left semi and left underscore semi is same, right? These are only how we can use them. So left outer are same, is in the same, left underscore anti and left anti are same, then left underscore semi and left semi are same, right? So this way you can use any of the names. So these are all same. Same goes for the right outer also, right? Right outer, right underscore outer. This way we can use them, right? So here again, airline delay, air time delay, arrival delay, air time, month, and plane year. We are converting them to integers, right? Here, and we are joining the planes on tail number with flights. So basically the main thing is like we are only going to join two tables based on the common column, right? So this seems to be the common column, and then here we are just describing it, printing model data. What my data is there. This is just printing the model data dot print schema. So print schema basically gives me in this way, right? Like what was my data type. Here again, what we are doing is like from here itself, we have just done some sort of transformations to make the data, available for my, data science models. So that's why here we are doing some sort of, aggregations, doing the fixes of my data sets. Basically here I'm just converting them into integer that we already did on the previous cell also. So this is just the repeated one. If I'm going to remove this also, this will work, right? Here we are doing some mean, standard deviation, spark minimum, spark maximum. So these are some of the statistics that we are finding out on different columns to count mean, standard deviation, spark minimum, spark maximum, and then similar way on other columns also, just to get the statistics. So from here onwards, this is basically the the data science models that we are going to apply, right? So here we are going to use different libraries which are mainly going to be used for data science purposes, right? Here we are just, again, with model data, we are creating a name plain age. And how we are creating what is the model year, what is the year minus plain year. Then is late, like why this is, we are creating one more column because we need to find out those, whether how my plane got delayed. So is late function based on this, wherever the model dot arrival delay is there, so how much it is going to be late. So based on the arrival delay, if it is greater than 0, we are taking it as late. Otherwise, like if arrival date delay is not greater than 0, it was not delayed. It either came earlier if it is, its value is negative, and if it is equal to 0, it means it arrived on time. Another is label. So we are labeling it, like if it is late, then we are casting it to integer. So it will give me the label for that. And then we are filtering, like if arrival delay is not null and arrival delay is not null and departure delay is not null, both are not null. This is also not null and this is also not null, and year time is also not null and plain year is not null. If all are those nulls, I'm just filtering those data so that only we can get if any one of them is going to be null. So either we have to provide them some sort of default values like 0 or what, otherwise it will again going to create the issues. So that's why these are some of the filter conditions that we have to apply based on our condition, because these are the business rules. Here we are not doing any nothing from our side. These are some of the checks that we have to do whenever we are going to work with. So if you see from cell 43 onwards, now we are using pandas, numpy, sklearn. These are the data science libraries are there, where we are going to use for pre-processing. For pre-processing, we are using label encoder. For linear model, we are using logistic regressions. Model selection, we are using train test split. So these are already inbuilt libraries that we have to use, right? So what I suggest you, well, like I'm going to send you this one. Just go through it, because now onwards it's all the data science part which is there. So some of the things even I don't have the idea, because I have not worked much on this data science libraries. But yeah, I've got some idea like how the classification, logistic regression works. But like say ROC or Oxcore, I have not used these libraries extensively. But what we can do is, like, we can check out what kind of data they are producing, how the models are using. So these are the these conversions, derived columns, that you have to just go through all those things, right? And how we are converting. So this is basically this here what we are trying to do is this model data model complete. It's my Spark data frame. So for this Spark data frame, I can convert it to pandas data frame. So here I'm converting it using 2 pandas. So I can directly convert, and using create Spark data frame, I can convert from data frame pandas data frame to back to my Spark data frame. So why we are converting this? Because some of the functions in pandas, they are straightforward functions. So what we can do is, as I told you earlier, like we can convert data frame to a table, and then do some transformations which are easier to done on the table itself, and then convert that table into a data frame. Similar way, here we can simultaneously we have to work in pandas as well as in Spark. The only difference is, like, pandas generally work on my single cluster, right? Single node cluster. So that's why we have to keep in mind, like whenever we are working,
we have to keep this thing in mind, that if we are working on a very huge data set, like in terms of when my data size is in millions, then we should not go with the pandas, right? Because pandas work on single node cluster. So if it has to do the partitioning and do the parallel processing, then pandas generally don't optimize the things. So they are going to be bottlenecks in some cases, but in most of the cases the pandas library is quite good in terms of utilizing those functions. So like these shape functions, then drop NA. Drop NA basically removes all of your NAs wherever it is null values. So it is used for cleaning my data sets. So this way we can use them wherever we find, because the data which is coming from the source, it is not going to be very clean data, because we have to clean the data. So now you see, initially data set was having 10,000 records, but 6 records were there. So after removing those, we rows removed, they have removed around 693 rows were there, which were having those noise data. So just for cleaning and all these purposes, we have to use these. Although we can do them in Spark also, but Spark takes more time, and some tweakings we have to do. But in pandas, we have got direct functionalities there, right? So you can just go through them, and if you find any issues, we can discuss, because this is what I just wanted to told you. From now onwards, it's all like here again, it's fill NA. So fill NA means like it is going to fill wherever I'm having missing values, so it will fill with mean values. So that's why we have created earlier mean, mode, standard deviations. So this is mainly for the imputation of the values, like wherever we are having some missing values are there. So we can generally, there are different ways we can either we can put wherever my data is missing, so that missing data can create it can deviate my final result. So to get the result, what we used to do is, there are different ways. Either we can remove those rows from the data set itself, if wherever I got null values are there or blank values are there for some of the columns. But again, if those columns are very less in number, let's say out of 10,000 we are having, let's say 100 200 values are there, so those are not going to impact a lot, so we can remove all those rows. But what if, like, if I'm having 2,000 rows are there, so if I'm removing 2,000 rows from 10,000 records, so it's going to be around 20%. So if I'm removing 20% of the data, so that is going to cost me a lot. So what I can do is, like, whatever I'm having the mean values, median values, or some other values I can put. This is one way. Another way is, like, I can put some default values also. So there are different ways of imputing the values, right? So you just go through it, and then we can see, like, if you find any issues, right? Apart from this, like, once you have done with it, like if you run everything, I just wanted to tell you, like, okay, my notebook is ready, and you are happy with the the reports or the results that you are getting. So what is going to be the next part? The next part is basically how you are going to deploy it. So deployment we'll see later, but once you have deployed it, I need to schedule it. So I just wanted to schedule it like on daily basis. It's on what frequency you want to run it. So you can just go to schedule here, and you can just add your schedule. So it's going to be my job name. So it's saying every day, every one day it is going to do, or you can check it, every 2 days, every 3 days, or from here also you can do it in hours or weeks or months, likewise, right? And also you can schedule it. This is the interval, then this is going to be scheduled like every day at what time, at 8 a.m. at let's say 8 a.m. I just wanted to schedule at 8 a.m. exactly at 8 a.m. So I can just pass it like this way, and it will work, right? and then I can just put some advanced settings also. So there are a lot of things. We'll see these things also in, like, it will go to notifications. And if right now we don't have any parameters, but we can add parameters, like what kind of parameters we want to pass at the runtime. Like there might be the cases like at runtime I need to pass some dynamic values, so I can pass those values, or also based on the environment to environment. Like right now we are in the development, so development to stage it will go, stage to production it will go. So there the parameters are going to be changed, so automatically we don't have to go and change those parameters. So those things we can also do with the help of this schedule at the runtime. We can automatically, those are going to picked up by from these parameters. So we can set n number of parameters, but those parameters again we have to set them, so that they should work dynamically. So here, like, we can just set the environment, and within the environment default value, what is going to be the default value. If nothing is set, so it will take that value. Default value works like that way, right? So this way we can just go through onto this one. I'm going to share this notebook with you. Let me share it right now and see if you can.
Is it possible to download the code and share it that one too? Because I cannot open the notebook as it is. So,
This which notebook?
this one I can import and then only I can open it, right?
Yeah. No. Let me share it with you here. I can go. And download it as C. I can download it as either DCB archive or IPython notebook, right? In these two ways you need to download. Otherwise, like, we can download as source file also, HTML, but in HTML it gives you a lot of HTML code and all. So IPython, either you can use IPython. Right now you are using IPython, so this time I'm going to give you DBC archive, right? Just
So
to,
if I do IPython, how it will be downloaded? It will
yeah,
download
this
it
is
in
the IPython code. IPython and DBC, this Databricks archival is there. So these are same, right?
I wanted to open it in the notepad. So how I can do that?
Yeah, Notepad, you can just open it in right Notepad and give it the language as Python. Select the language as Python, so it will be available to you. Let me show you here itself, right?
Mhm.
Let me download it first. Okay. So I'm going to download it as DBC archive. You see, it's got downloaded.
Okay.
I'm opening it. Right click. Open the new Notepad. Okay, it's not opening. Yeah, here it won't open, but let me do it then. IPython. IPython will be opening Python mode. See.
Yeah.
Why it is opening like this? It should be IPYNB file. Language. It seems to be in HTML actually. This is my HTML code, not the IPython one. It is not taking this way. It should work like this. Source file. If you want to open it directly, you can edit it as source file. So within the source file itself, it by default take it as Python.
That's fine. Let me copy it from here and then I'll put it in the notebook.
See this
So I started
PySpark.
taking.
So you can if you want to open it in Notepad, so open it as source file. Close this. And you can just import it as DBC or IPython, so it will directly be open. See, so this is opening as my Python file, right? By default. So cell by cell, wherever you see this command, it means it's a new cell, right?
Okay.
Yeah. So let me share that with you. Oops. Both I'm going to share you DBC as well as this file, right?
Okay.
You can use them. So, before the next session, you have to finish this, right?
Yeah.
Okay. So I'm stopping here because I think it's going to be late for Sharmila. It's already 9, right? So 11:30 would be there, right?
Yes.
Yeah. Okay. So whatever we have discussed today, do you have any questions, queries? Let me know. So just go through the concepts. Once you have done with the concept, the only thing is like we have to, we are going to do a lot of practice. So next time I'm going to show you like how we are going to build a DLT pipeline, and we'll try to show you like if the time will allow us to that how we can use this deployment, right? How we are going to deploy it using Databricks asset bundles to higher environments, like to stage development to stage to prod, right? So there are different ways you can do it. Yeah, that is comes under CI/CD DevOps one, but we'll see, and then probably we'll do some optimizations also, right, in the next session, maybe in
Okay.
next week, basically on Saturday, Sundays, right? So again, optimizations are going to be two ways. Like one is related to Spark, another optimizations which are we are applying those in the Spark, but apart from Spark, there are a lot of transformations that we can apply from the Databricks side also, which really plays an important role, right? So those also you need to know, right? So we'll talk about all those things, right? These are basically the advanced topics in comes under Databricks. We'll also talk about order loaders and all, right? So yeah, but what I want is like from your side, right? I need more progress, right? Once I'll be confident, okay, you are doing it, so we can move, a little faster, because what I've seen is like we are just not moving to the pace that we should, right? So, but I don't want you to be, like I'm going faster, but you are not able to do it. But that's what I want. Like you have got around full week time. So just even if you are just giving 1 hour or so, that will be enough, right? But just try to escalate the things, right? We need to move a little faster, otherwise like it's going to take longer time, and that I don't want to do it. For me it's fine, like if I'm going to take 10-15 days, like 2 weeks more, that is fine for me, but I want that you should have that pace, right?
All
Right.
right.
Okay.
Mhm.
Any other questions, queries, any inputs, any feedbacks, just let me know, right? If you are if you feel anything, just let me know. We can just adjust those things. If you're not getting anything, if you want something else to be done, any feedbacks, anything that you want to give me or to Vineet, I'm happy to go with those things, like whatever I'm following the way that we are doing. If you want to go in and some different way, or it's fine, just I need some sort of feedback from you guys.
Okay.
Okay, I think then we are good to go. Thanks everyone, have a nice day, nice weekend.
Thank you. Thank you. Bye.
Bye.